Hi everyone. My name is Jake
Yay.
Luciani. I am the chief architect at DataStax, where we work on all things Apache Cassandra. I'm going to be talking about one of our projects, which is has become our main cloud service, and it's about how we changed Apache Cassandra to work more natively on Kubernetes. I'm going to call Kubernetes K8 because I have a stutter and it's easier for me. So let's talk about Apache Cassandra. A lot of you folks are probably aware of it. You basically have a peer-to-peer ring of nodes where all the nodes do the same thing. It's a shared nothing. And the issue is for us, it works great as a standalone service. There's also Cassandra, which runs pure Apache Cassandra in Kubernetes using operators. Us running Cassandra as a service, we have slightly different needs. And we want to be able to provide the best service we can on K8 itself. So some of the downsides that we ran into is Cassandra runs on assumes it's running on fixed hardware. It was released back in 2008. 2009. So this was all before Kubernetes really hit the mainstream. So there's a impedance mismatch between how Cassandra wants to do things and how K8 does. And basically, as I mentioned before, Cassandra has all nodes perform all of the same actions. They all compact, they all stream, they all repair. And the problem with that is if you want to scale, you basically have to scale all of your resources at once. You basically have to scale your data, your compute, and your network in these sort of larger chunks, which is not ideal for a cloud service. It gets very expensive. So another issue we ran into is that all of the nodes need to talk to all of the nodes. This is something that as you scale, it just becomes complicated for us to track, who's talking to who. It becomes very rack heavy. And finally, last couple of points, it's not a multi-tenant system, and it's not built to auto scale because it has to stream data around, and that streaming affects the nodes. So something that we wanted to do as a project is to focus on how can we make Cassandra more native to K8s and focus on separating compute from storage. By what we wanted was to be able to scale across different axes. We wanted to be able to scale our data separate from our CPU, from our and from our memory. We wanted to make it very quick and cheap to scale up and down. And as I mentioned before, Cassandra was built before all of these all of Kubernetes existed. So we wanted to kind of take a look at what could we use that's built in to Kubernetes and make it the foundation of running Cassandra on it. So focus more on the Cassandra storage engine and less on like how the services connect to each other, maintain metadata and all that stuff. There's lots of existing tools. So we're trying to, to make our jobs easier by cutting down the surface area. And we also obviously, this conference has been talking a lot about operators. We wanted really to get into operators controlling this system, because breaking Cassandra into pieces, which is the next slide, we basically took Cassandra, we kind of Hulk smashed it and broke it into lots of different things. Now, the key bit, which is our key insight here, was in order to separate compute from storage, we decided to make our data, the source of truth for our data, be S3 or EKS, or sorry, not EKS, S3 or Azure storage, or GCS, or Minio, or the object storage is kind of a core cloud foundational piece. So we decided to make our source of truth that service. So what this allows us to do is to basically allow our data to separate from our nodes, and this is why we call it serverless. All of the services here are ephemeral. You can upgrade the whole thing. You can bring the whole thing down. You can scale it up, and all the data stays intact. It also means that you don't have to stream data from node to node. Each node can grab its data out of object storage. So to break it down, we basically broke off our coordination services into a separate service. It's called Stargate. It's open source. If you go to stargate.io, it basically allows REST, GraphQL, CQL, gRPC APIs. The other thing that we did is focus on, we basically allowed our data, since the data lives in S3, we're able to build separate surfaces which hang off of that. Specifically, compaction is now its own scalable service. Repair is its own scalable service. We use etcd to basically enforce the metadata. And one of the key things here, for example, is if you take a snapshot of what the live data set is in etcd, since all the data lives in S3, you automatically get a backup. So that's another value there. So real quickly, you can see how we broke things out. There's basically your user app uses CQL. Ingress layer goes to Stargate. It goes to the data nodes, which flush the data to S3. It also serves the data off of those nodes. And another key insight here is, since the data lives in S3, we can use ephemeral storage as a high-speed cache. So all of our data is running off of NVMEs. Our background services like compaction also run off of that. Our cleaners, which basically clean up data which is no longer used. You can see we're using Prom for monitoring. We basically built our operators to kind of manage this stack. S3 is our data plane, and etcd is our metadata storage layer. Looking at my time, I think I'm done. So couple QR codes here. There's one for $200 to use this service if you'd like, and the other one is a white paper on the right, which explains a lot of this stuff in more detail. Thank you for your time.